Bismillahirrahmanirrahim. How are you, students? Today we will study unit number 4, lecture number 27. Chapter name is Turning Effect of Forces. Today we will do the numerical turning effect of forces. The first numerical, this is the chapter name, unit number 4. The first numerical is find the resultant of the following forces. 10 Newton along x-axis, 6 Newton along y-axis and 4 Newton along negative axis. So you will draw horizontal and vertical lines. This is x-axis, this is y-axis. 10 Newton along x-axis. So a force of F1 is equal to 10 Newton along x-axis and 6 Newton along y-axis. So 6 Newton is equal to F2 is equal to 6 Newton and along y-axis and 4 Newton along negative x-axis. So 4 Newton is in this direction. F3 is equal to 4 Newton. So this is 10 Newton, 4 Newton, 6 Newton. So 10 Newton is in this direction and 4 Newton is along the negative axis. So we will take the difference of these two. 4 Newton will cancel the effect of 10 Newton and 6 Newton is left. So at the along x-axis a force of 6 Newton is acting. Now we have to calculate the resultant force and the theta. This is the formula for the resultant vector which we done in the resolution of force or vectors. Resolution of forces. So you will use this formula, you will calculate the magnitude. Fx is 6 Newton along x-axis and along y-axis force is 6 Newton. So you will get 6 square 36 36 72, you will get 8.5. Similarly we know that theta is equal to tangent inverse fy divided by fx. Tangent theta we know that is equal to perpendicular by base. So perpendicular is y and base is fx. So you will calculate the angle which is 45 degree. Now the next numerical is find the perpendicular component of a force of 50 Newton making an angle of 30 degree with x-axis. So this is a force of 50 Newton. This is the horizontal component and this is the vertical component, and we have to calculate this one. These are called the perpendicular component. So question mark, here is question mark. This is the data, this we have to find. These are the formula. If x is equal to f cos theta, you will get the answer, this one and this one. So do the calculation, and if you have any query you can ask in Zoom class. So fx is equal to f cos theta and fy is equal to f sin theta. You can calculate these equation by using these the fx and fy by using these equation. Now find the magnitude and direction of a force if its x component is 12 Newton and y component is 5 Newton. This is y component, this is a x component. Fx is equal to 12 Newton and Fy is equal to 5 Newton. These are given. Find the force and theta. Force, theta. Do it. Now Fx is calculated by this formula, theta by this formula. You will get the answer. Next, a force of 100 Newton is applied perpendicularly on a spanner at a distance of 10 cm from fulcrum, point of rotation. Find the torque produced by the force. So let's say force is applied here and this is point of rotation. This distance is 10 cm. Find the torque. This here the force is given 100 Newton. So torque is equal to R cross F. Use this formula, you can calculate this one. Convert centimeter into meter. A force is acting on a perpendicular on a body making an angle of 30 degree with the horizontal. The horizontal component of the force is 20 Newton. Find the force. Horizontal component is given and it is 20 Newton. It is written here. Theta is this one. Now we have the formula Fx is equal to F cos theta. Use this formula, determine the determine the resultant force. Fx is equal to F cos theta divided by cos theta divided by cos theta. So F is equal to Fx divided by cos theta. Now next numerical is now we will jump to the numerical number 6. Here is page problem. Now the steering of a car has a radius of this one. This is the steering of a car. Radius is 16 centimeter is equal to 0.16 meter divided by 100. When you want to convert centimeter into meter, you will divide by 100. C means centi is a prefix and is equal to 100. 10 raised to power 2. Find the torque produced by a couple of. We have to calculate the torque. This is the formula for torque. You will find torque and then find the couple. Couple is actually 2 times of torque. 2 multiplied by right F cross R. We have written the value of torque. Now a picture frame is hanging by 2 vertical string. The tension in the string is 3.8 and 4.8 4.4. Find the weight of the picture. This is one component, this is the other component. For example, here is this is one body, this is the other body. Its weight is 3.8 and its weight is 4.4 Newton. Here is Fy2 component, here is Fy1 component. So Fy1 is equal to, write mg, this is 3.8 Newton. This mg is equal to this. According to the first condition of equilibrium, sum of forces must be equal to 0. Upward force is equal to downward force. The first condition stated summation of forces is acting horizontally or vertically will be equal to 0. So this is vertical, so write Fy. Now our upward force is equal to downward force. This is the upward force, this is the downward. You will calculate this one. Now you can calculate F1 by T1 separately and T2 separately, and total is equal to T1 plus T2. Now a nut has been tightened by a force of 200 Newton. Force is how much? 200 Newton. The moment arm per 200 force is 10 centimeter. Converted into meter. F2 is 150 Newton. If we open the same nut with a spinner exerting a force of 150 Newton, find the moment arm. So torque produced tau1 is equal to tau2. This is the torque produced by F1 and is equal to R1 is equal to F2 R2. If you can tight by exerting more force by keeping the moment arm different, the nut will need the same force to open or to tight. Whether you exert more force or less force, torque will be remain the same. Moment arm will be different. Force will be different. Here force is more. Here force is less. So here force is more. Moment arm will be less. Here force is less. Moment arm will be more. So you will write 200 multiplied by 10 centimeter is equal to R2 multiplied by 150. So R2 is equal to 200 multiplied by 10 centimeter divided by 150. 0 is cancelled with 0. 5 threes are 15, 5 fours are 20, 40 divided by, it's most probably 13 point something. Here torque produced by F1 will be equal to torque produced by F2. If forces are different, moment arm will be different. You can use this equation, you can solve this one. A block of mass 10 kg is suspended at a distance of 20 cm from the center of an unknown bar 10 meter long. This is the mass, this is the force. What is the force required to balance it at its center of gravity by applying the force at the other end of the bar? This is radius, this is R2, 10 centimeter and 20 centimeter. So we should make calculation. Now if 2 we have to find, use this formula, you can find if 2. This part is finished, so I will revise. Now in Zoom class, you asked about resolution of forces, so I will do it again for you people. Resolution is if you have a single force in this direction. Let's say this is y-axis and this is x-axis. We have a force F in this direction, force F. So if you from this point, let's say it is A and it is O, draw perpendicular on y-axis, then this is called Fx, because this is the component of force, the effective component of force along x-axis, and draw perpendicular from this point on y-axis. This will be the y component, effective component of force along y-axis. So if y is the vertical component, vertical component, and Fx is the horizontal component. Fx is the horizontal component. So as we draw a parallel line to this here, this is Fy, as this is a Fy, because it is equal to magnitude, these two are equal, these two are equal, so it is called Fy and this is called Fx. So it makes an angle of 90 degree with each other, it make an angle of 90 degree with each other, so they are called perpendicular component, perpendicular component, perpendicular component, or rectangular component, perpendicular component or rectangular component. Now we have to find these component, the magnitude of these component, the component, horizontal component, the component of force, the effective component of force which is acting along x-axis, acting along x-axis is called horizontal component, and the effective component acting along y-axis, acting along y-axis is called vertical component. This is the horizontal component and this is the vertical component. So using trigonometric ratio you can find, as you know that we draw the diagram like this, this is Fx, this is Fy, and this is the force that we resolve, F. Now as you know that sine theta is equal to perpendicular by hypotenuse, so sine theta is equal to perpendicular is Fy divided by F. So Fy is equal to F sine theta, and cos theta is equal to, cos theta is equal to base by hypotenuse. So cos theta is equal to base is equal to fx divided by f. Fx is equal to f cos theta. Now by Pythagoras theorem, hypotenuse whole square is equal to base square plus perpendicular square. So f square is equal to hypotenuse, fx is the base and fy is the perpendicular. So f is equal to under root fx square plus fy square. Similarly, we can find theta. Tangent theta is equal to perpendicular by base. Theta is equal to tangent inverse. This will be transferred to other side, so you will write tan minus 1 fy divided by fx. You will get the angle. So resolution of forces is basically the conversion of force into its rectangular components, which make an angle of 90 degrees with each other. Now resolution of forces is what? The splitting up of a single vector. Splitting up of a single vector into its rectangular component, into its perpendicular component. Now uh, now rigid body. Any body which cannot be compressed, which cannot be compressed, in which deformation cannot be produced, in which deformation cannot be produced. uh, let's write the trigonometric ratio. This is theta, this is sine theta, cos theta, tangent theta. Make the column 0, 30, 45, 60, 90. So start from 0, 0, 1, 2, 3, 4. How to write, how to memorize this table? Now in this column the maximum value is 4, so divide each number by 4. 0 by 4, 1 by 4, 2 by 4, 3 by 4 and 4 by 4. So from this we will write 0. From this we will get 1 by 2, 1 by 4. This 2 is cancelled and this 2 we will get 1 by 2. This will get 3 by 4 and from this we will get 1. So take the square root of each number. Here we will get 0, here we will get 1 and here we will get 2. From this number we will get 1 divided by under root 2. From this we will get under root 3 divided by 2. From this we will get 1. I will do again because it's not give a good look. Now draw a table like this. Here theta 0, 30 degree, 45 degree, 60 degree and 90 degree. Here we will write sine theta, here we will write cos theta, here we will write tangent theta. So you will write 0, 1, 2, 3 and 4. In this column maximum number is 4, so divide by 4. 0 divided by 4, 1 by 4, 2 by 4, 3 by 4 and 4 by 4. From this we will get 0, from this we will get 1 by 4, from this we will get 1 by 2, from this we will get 3 by 4 and here we will get 1. Take the square root. If you take square root of this you will get 0, so write 0 here and 0 here. From the top and first column from the top and second column from the bottom. Here we will get square root, we will get 1. Square root of 4 we will get 2. So here we will write 1 by 2 and here we will write 1 by 2. This 1 by under root 2. So 1 by under root 2. 1 by under root 2. Here we will get under root 3 by 2. So write under root 3 by 2. Under root 3 by 2. Here we will get 1, 1, 1. Now 0 divided by 1. Divide this column by this column. You will get tangent. 0 divided by 1 we will get 0. 1 divided by 2. 1 divided by 2 divided by under root 3 by 2. 1 by 2 multiplied by 2 by under root 3. When it is converted into multiplication it will get inverted. So 1 by under root 3. 1 by under root 3. When this column is divided by this column you will get 1. When this column is divided by the cos column we will get under root 3. 1 divided by 0. 1 divided by 0 is undetermined form. So here we will write infinity. So this is the way of memorizing this table. Now today we have done numerical. Tomorrow we will do the short answers and after that the revision will start. If you have any query you can ask in Zoom class. Thank you students. Allah Hafiz. Wish you best of luck.